Ni hao, and welcome to the second part of our Unit 5 presentation on Advanced Data Modeling for CIS 3107 Database Modeling. We will be covering sections 5.2 and 5.3 in our text. In this second presentation, we will learn how entity clusters are used to represent multiple entities and relationships, what characteristics make good primary keys, as well as how to select them. An entity cluster is a, quote, virtual, end quote, entity type used to represent multiple entities and relationships in the ERD. An entity cluster is formed by combining multiple interrelated entities into a single abstract entity object. An entity cluster is considered, quote, virtual, end quote, or, quote, abstract, end quote, in the sense that it is not actually an entity in the final ERD. Instead, it is a temporary entity used to represent multiple entities and relationships with the purpose of simplifying the ERD and thus enhancing its readability and avoiding the display of attributes to eliminate complications that result when the inheritance rules change. Figure 5.5 illustrates the use of entity clusters based on the tiny college example. The ERD contains two entity clusters in blue: offering, which groups the semester, course, and class entities and relationships; location, which groups the room and building entities and relationships. Note, also the ERD does not show attributes for entities. When using entity clusters, the key attributes of the combined entities are no longer available. Without the key attributes, primary key inheritance rules change. In turn, the change in the inheritance rules can have undesirable consequences, such as changes in the relationships and the loss of foreign key attributes from some entities. To eliminate those problems, the general rule is to avoid the display of attributes when entity clusters are used. Arguably, the most important characteristic of an entity is its primary key. A primary key is a single attribute or some combination of attributes which uniquely identifies each entity instance. The primary key's function is to guarantee entity integrity. Furthermore, primary keys and foreign keys work together to implement relationships in the relational model. Therefore, the importance of properly selecting the primary key has a direct bearing on the efficiency and effectiveness of database implementation. A natural key or natural identifier is a real-world and accepted identifier used to uniquely distinguish and identify real-world objects. As its name implies, a natural key is familiar to the end user and forms part of their day-to-day business vocabulary. Usually, if an entity has a natural identifier, a data modeler uses it as the primary key of the entity being modeled. Generally, most natural keys make acceptable primary key identifiers. A primary key, PK, must be able to guarantee unique values and cannot contain nulls. The PK should not have embedded semantic meaning other than to uniquely identify each entity instance. An attribute with embedded semantic meaning is probably better used as a descriptive characteristic of the entity than as an identifier. If an attribute has semantic meaning, it might be subject to updates, which is why names do not make good primary keys. The PK should be permanent and unchangeable. A PK should also be irreducible, that is, to have a minimum number of attributes possible. Single attribute primary keys are desirable, but not required, as they simplify the implementation of foreign keys. Unique values can be better managed when they are numeric. Because the database can use internal routines to implement a counter-style attribute that automatically increments values, often called an auto number or unique identifier, with the addition of each new row. The selected primary key must not be composed of any attributes that might be considered a security risk or violation, such as our social security numbers. Although a primary key strives to use the minimum number of attributes possible, composite primary keys are permitted in a model. In fact, composite primary keys are particularly useful in two cases. One, as identifiers of composite entities in which each primary key combination is allowed only once in the many-to-many relationship. 2. As identifiers of weak entities in which the weak entity has a strong identifying relationship with the parent entity. To illustrate the first case in Figure 5.6, assume that you have a student entity set and a class entity set. In addition, assume that those two sets are related in a many-to-many relationship via an enroll entity set, in which each student/class combination may appear only once in the composite entity. The composite primary key automatically provides the benefit of ensuring that there cannot be duplicate values. That is, it ensures that the same student cannot enroll more than once in the same class. In the second case, identifiers of weak entities is represented in two ways: as a real-world object that is existence dependent on another real-world object, employee, and their dependent, or as a real object that is represented in the data model as two separate entities in a strong identifying relationships, such as invoice and its line entity. In both situations, having a strong identifying relationship ensures that the dependent entity can exist only when it is related to the parent entity. In some cases, a primary key does not exist in the real world, or the existing natural key might not be a suitable primary key. In these cases, it is standard practice to create a surrogate key, which is a primary key created by the database designer to simplify the identification of entity instances. Surrogate primary keys are especially helpful when there is no natural key, when the selected candidate key has embedded semantic contents, or when the selected candidate key is too long or cumbersome. However, there is a trade-off. If you use a surrogate key, you must ensure that the candidate key of the entity in question performs properly through the use of, quote, unique index, end quote, and, quote, not null, end quote, constraints. Given the data shown in Table 5.4, what primary key would you suggest? In this case, there is no simple natural key that could be used as a primary key in the model. One might suggest a composite key options of date, time, _start, room for the event entity. Yet one event may use resources, and that same resource may be used for many events. Given the business rules, the many-to-many relationship between resource and event would be represented via the EVNTRSC composite entity with a composite primary key as follows: EVNTRSC, parentheses date, time, _start, room, RSC _ID, QT used, parentheses. You now have a lengthy 4-attribute composite primary key. What would happen if the EVNTRSC entity's primary key were inherited by another existent dependent entity? At this point, you can see that the composite primary key could make the database implementation and program coding unnecessarily complex. The preferred alternative is to use a numeric single-attribute surrogate primary key. In summary, an entity cluster is a, quote, virtual, end quote, entity type used to represent multiple entities and relationships in the ERD. An entity cluster is formed by combining multiple interrelated entities and relationships into a single abstract entity object. Natural keys are identifiers that exist in the real world. Natural keys sometimes make good primary keys, but not always. Primary keys have unique values. They should be non-intelligent, they must not change over time, and they are preferably numeric and composed of a single attribute. Composite keys are useful to represent many-to-many relationships and weak, strong identifying entities. Surrogate primary keys are useful when there is no natural key that makes a suitable primary key. When the primary key is a composite primary key with multiple data types, or when the primary key is too long to be usable. Thank you for viewing our Unit 5 Part 2 presentation. The diagrams and content of this presentation were derived from our textbook. For a more detailed treatment of these concepts, please review pages 176 to 181 in our text.